So hello, my name is Gregor. I'm gonna talk about writing games in Ruby. But let's first start with the famous example of measuring the coastline, because we could open a map, draw this 100 kilometer segment and call it a day. But it's not very accurate. We could be more accurate, so we could outline our coastline with these kilometer segments. We would get completely different results. But then again, we could be even more accurate. We could go to the ground, start measuring things more accurately. We would get completely different results. But then again, we could be even more accurate and start measuring the grains of sand and get completely different results. So it's like measuring things is hard. And that brings me to games, because games are these highly coupled systems. We have player actions and economy and AI, and everything has to work together, which makes it a great way to test things. So first thing, in order to create a game, we need a game engine. And I started with more traditional route, which means I tested Unity and Godot and more popular game engines. But then I wanted to check if I can do this in Ruby, but I encountered a problem because no library is currently supported. So then I did some tests with JavaScript, but I ran into so many troubles, so many problems that it wasn't even worth trying. But then I find out that there is actually a game engine written in Ruby, and it's called Dragon Ruby. And it's based on mruby on technical side. mruby is this lightweight implementation of Ruby designed for embedding. It's used, for example, by Shopify in order to run customer-provided scripts safely. So, okay, how to make a game? First, we need to download some assets. So I found this city building kind of thing. In practice, a tile sheet looks more like this. And our entire logic of the game, or I would say every game engine has this general concept of a tick, and in Dragon Ruby there is actually just a method tick, and that basically means our player actions, all the logic, everything has to be calculated 60 times a second, and this method runs 60 times a second. And there are a lot of things that we have to implement. My assets are in isometric perspective, so I had to implement isometric camera. With 2D games, there is this problem with perspective, so it's not that obvious what should be in front of the camera. And in order to solve it, there is this solution called Z-sorting. And in this case, we don't our game to run on Rails. And since this is a city building kind of game, so we will have cars, and we want those cars to find their destinations in a short path. And for this purpose, A-star algorithm is perfect, because it not only will find the shortest path, but also can take into account congestion. And the logic that no European brain cannot comprehend is always stop intersection. Because when I see all these stop signs all the way, then I think the traffic should stop to halt. But my coding agents had no troubles implementing that, and this was really a group project, because I used basically every tool available in order to create this, and a lot of plans. So one important lesson I learned creating all of this is that flexibility is key, because there are a lot of different tools that we can use, and there is no, like, we have to be flexible and use different tools to approach our results. And for a practical example, let's say we wanted to change our testing library, and instead of telling our coding agents what to do, we could set a goal, which means set our destination, and then a coding agent will figure out the way to do this. And this is an example of such prompt. Okay, so how this game looks, how this everything works. So I'll run it from the very beginning. And this is very simple. I can move it actually first. So I will build a road like this. And if I created 2 buildings, then a car is spawned. And to prove that this is all dynamic, okay. The car will now change the direction because this is shortest path. And when I start building more things, then our simulation is ongoing and everything is dynamic, everything works. So this is like a very simple thing that took a lot of time, and it's way complicated because it's way more complicated in terms of code than it looks. But I encountered a problem, and this problem is called Fable 5, because suddenly I'm seeing everywhere that people are creating very impressive games on JavaScript with Fable 5. So the question was, can I recreate this in Ruby? Especially since Dragon Ruby there is not many examples of code on the internet, so it can be hard for LLMs to learn how to create anything in that. But it was like 2 weeks ago, and I didn't have time to like recreate my entire presentation. So I just recreated something more recognizable. And this is my entire prompt. I use plan mode, and my prompt said, this folder contains Dragon Ruby game engine, folder docs has documentation, create a game inspired by Mario, and recreate world 1-1, which is the famous one, the one that everyone can recognize. Okay, so how does it look like? As you can see, everything that you see here is completely generated by Fable. So every asset is completely generated. After running this first prompt, I didn't touch anything. And all the mechanics of Mario game, as you can see, everything works, everything looks pretty good. So we can call it a success. And the cool thing about running this in Ruby instead of JavaScript is that I can actually build an iOS version and an Android version, and this can actually be a real product that I can put into the stores and makes millions of dollars, right? So I can, and that's entire level. So in short, you can basically forget about my entire presentation and just one-shot entire game for the idea once the US government allow us to use Fable 5 again. And thank you for having me.